So we're doing our solving the equations. We're doing it in one step, okay? And text box. An expression is a mathematical sentence with, oh, wait. I'm leaving these blank at the top for a minute. I got to come back to them. I got to think about those. Someone else wrote it, and that's not what I would say. We're going to be working on the equations first. The big thing you have to remember about equations, yes, I could solve this using mental math. Yes, I can solve this using mental math, but we need to get in the habit and the practice of how to show your work, because as we progress, showing your work is going to matter more and more as you move yourself through the math levels. Showing your work matters more and more. Okay, so yes, I know how to do this by mental math, but we're not doing that. I'm going to show you the correct way to show your work. Okay. I do know that this blank right here is to solve. I don't know what that first sentence says. This is what happens when you get stuff from other people. To solve an equation is the solution to the equation. Let's say it the right way. The solution to the equation is the answer to what the variable is, okay? Still not looking at that one. Okay, so when we go to solve it, what we have to do is get the variable alone. That means by itself on one side of the equal sign. Okay. To do that, we have to do the opposite operation that's already there. To do that, we have to do the opposite operation from what's already there. Okay. So if we're adding a number to this problem, right, I need to get the x all by itself. I need to undo this -7. And the way I undo negatives is by taking positives. So I'm going to add 7 to both sides of the equal sign. Okay, we're going to add 7 to both sides of the equal sign. And we're even going to go ahead and make it clear we have to keep these separate, because it's like a scale. You have to keep it balanced. Whatever you do to the left side, you have to do to the right side. Now, what ends up happening is if I have x minus 7, and then I add 7, the two 7s will cancel each other out, right? They'll offset each other. So those two 7s become the big 0. And if I add 0 to something, it doesn't change anything. So it's just the x that's left over. Okay? Just the x is left behind. Let's see if I could shorten this a little bit. Can I shorten it? Come on, work with me, dude. No. So I am going to put a new line in because I want the equal sign. Okay, all that's going to be left is x because 7 minus 7 is 0. Okay, all that's going to be left is the x. 7 minus 7 is 0. And then we combine like terms on the other side, though. It now says 19 plus a 7. What is a 19 plus a 7 going to be? What does a 19 plus a 7 equal? Yep, 26. So for this situation, if my x is 26, I will get a true answer. Okay, if my x is 26, I will get a true answer. Let me zoom in a little bit. Got to move something, 1 second. This is a little better. See, the equal sign shows up now. Okay. So the goal is to make whatever's with the x go away. And for adding and subtracting, that's making the big 0. Okay. You want to turn it into 0. So this was a -7. If I add 7 to it, it becomes 0. But whatever I do to the left side, I have to do the right side. So we're going to go check. Okay, we're going to go show our check, Kevin. Okay, our check is doing the math on the calculator. Okay, so we need to check, does 26 minus 7 get us 19? So let's go look. Let's go look. We'll switch on the calculator and we'll go look just to be sure. Okay, 26 minus 7, enter, 19. So we got it right. Okay, so that is our answer. That's our check. So we're going to go double check. We're going to write it down. We're going to check that it works in the calculator. Check. We got it right. So what we did was go ahead and take the opposite of what's with the x so that we could turn it into 0. And by turning it into 0, the x is by itself, isolated. But whatever we do to the left side, we have to do to the right side. Okay. So that was starting with the subtracting. So we had to add to make it go away. Now, if we start with a add, we're going to have to do subtract to make it go away. So I'm going to have to subtract 4, right? I'm going to put my line in to tell me that's my boundary. I have to make sure whatever goes on one side of the line has to be on the other side also. So my -4 has to be over here also, because it's a balance, it's a scale. Whatever you do to the left side, you must do to the right side as well. Okay. +4, -4, what did we make? +4, -4, what did we make? What's a +4 minus a 4? What do we get? If I add 4 and then subtract 4, what's the answer to adding 4 and subtracting a 4? Should be. Oh, I know what it is. I forgot to come back from the calculator. I'm sorry. There we go. Okay, so because of adding, right, we have to do the opposite. If I have a +4 with a -4, what does that make? What number is that? +4 with -4, what number is that? 0. So I get to cross them out because it became the big 0. My x is all that's left. I need to figure out the other side of the equation now. And it says 6 take away 4. So what's the answer to 6 take away 4? What's the answer to 6 take away 4? 2. Okay, and we're going to go check it. Remember, if you double click, it'll make the box show up again as long as the equation's highlighted on the side. Okay, so it says 2 plus 4 equals 6. I don't think I need a calculator for that, do I? Do I need a calculator to say that this is true? That 2 plus 4 makes 6? Do you need me to use the calculator to prove that? Well, do you guys need me to go back to the calculator and put in 2 plus 4 and make sure it's 6? Or do you guys trust that that's true? Okay, so we can say check. All right, so if it starts as a subtract first, we have to add to make the big 0. But whatever we add to the left side, we have to add to the right. If it starts as an add first, we have to subtract the same numbers with the x so that it becomes a big 0. But whatever we do to the left side, we have to do the right. Okay. Now, x over 3. What does over mean? What math operation was over again? Division. So whatever we do division, we have to undo. So notice it started as subtraction, so we did the opposite operation, addition. It started as addition, so we did the opposite operation, subtraction. We are now starting as division. What is the opposite operation of division? What's the undo operation for division? Multiplication. So the way we're going to show this, get our parentheses, x over 3, close it. Wait, first we have to get off it and close it. Times, now we have to multiply to get that 3 from being dividing. So we're going to multiply by 3 because we need to undo the 3. Okay, we need to undo the 3. So that's why we're multiplying by 3, because we have to undo the 3. The x needs to stay, the 3 needs to go. Okay, we move this guy over so we can put our fence. Whatever we do to the left side, we have to do to the right. We multiplied on the left, so we have to multiply on the right. So the right side's now going to say 5 times 3. I'm going to change its size so it matches its buddy on the other side, though. Okay. So for multiplication and division, we don't want a 0. We want to turn it into the big 1, because 3 divided by 3 turn into the number 1. And when we multiply by 1, it doesn't matter. We already talked about that earlier. Multiplying by 1 doesn't matter. Okay. So in multiply and divide, your goal is to get the big 1. Turn what's with the variable into the number 1, because multiplying by 1 changes nothing. It's a multiplicative inverse. That's the fancy words for it. Okay. For adding and subtracting, you want to turn it into 0, because 0 is what won't change anything. If we add 0 to it, it doesn't change anything. Okay. So for adding and subtracting, your goal is to turn it into 0. For multiplying and dividing, your goal is to turn it into 1. Okay. The way we turn the adding and subtracting into 0 is if it starts add, we subtract. If we start subtract, we add. Okay. The way we turn multiply and divide into ones is we do the opposite. This started with division, so now we had to multiply to make that fix. So we're going to go check our answer now. This says 15 over 3, 15 divided by 3, should get us 5. Do we agree with that? Or do we need to put it in the calculator to check it? Okay. So we know that 15 divided by 3 is 5, and we're good. So check. Nope, not the one I wanted. I want this guy. I want a check mark. Okay, so we're doing the opposite of what's already there. So what does it mean? 6 stuck with the X, Emmanuel. What does it mean if the 6 is stuck to the X? Add, subtract, multiply, or divide. Okay, it means multiply. So we have to undo multiply. What's the opposite of multiplying again? What's the opposite of multiplying again? Dividing. So we're going to go divide to turn it into 1, because when you divide a number by itself, and it's the number that we're looking at, that becomes 0. That becomes 1, right? 6 divided by 6 is the number 1. Yes? And we don't need to multiply by the number 1. So that was the big 1. But whatever we do to the left side, we have to do to the right side. And then we have our final answer. Our X is left on the left side is going to equal, nope, 18 divided by 6. So what's that? What is 18 divided by 6? 3. Okay. So we're going to go put it into the check. This says 6 times 3 has to get us 18. Do we know that that is true? Yes. So we get to check mark it. We get to check mark it. Okay. Let me go bring up the other people's master to see what those words at the top were supposed to say, because those aren't sentences that make sense to me, but they're probably taking them directly from the book, and sometimes the book says things really weird. Okay. Questions about that? So if I told you, if I gave you a problem and I said, we're doing some practice down here. Right idea, wrong thing. I want my text box. Blue, blue, that'll work. Okay. And our first practice problem . Now we are not going to solve. I just want you to tell me what we're supposed to do to get rid of the 4. How do we get rid of the 4? What are we going to do to get rid of the 4? That's what you're answering. To get rid of the 4, I need to what? Remember, we have to do the opposite of what we see. So what are we going to have to do? Are we trying to get a big 0 or a big 1? Think about it. Are we trying to make a big 0 because when we add 0 or subtract 0, it doesn't matter? Or are we trying to get a big 1 because we multiply or divide by 1 and it doesn't matter? So what do we need to do so the X is all by itself? What do I need to do? I don't think that there's a divide needed. I don't see a multiply with the x. I have to do what's with the x. What do I need to do to get the x all by itself? Oh, I need to add x. Oh, I need to add 4, correction. Because I have to undo what the 4 already is. The 4 is already a minus 4, so I need to add 4 to make big 0. Okay. We're going to do another one. We're not actually solving, we're just talking about process, right? All right, here we go. I did the wrong box. Oops. Okay, same thing. To get rid of 2, I need 2. What do we need to do to move that 2 out of there? What do we need to do to move that 2 out of there? So what is it now? Remember, we have to do the opposite. We always have to do the opposite to make it move. So what do we need to do? We need to multiply. To multiply by 2 to make, which one are we making? Big 0 or big 1? If I multiply 2 times half, because that's on the bottom, it's a half, am I going to make a 0 or am I going to make a 1? If I multiply 2 times a half, do I make a 0 or do I make a 1? Yes, so this makes our big 1. Okay. Let me move these out of the way. Okay, let's see. How about, okay, to get rid of the 3, I need to undo how that 3 is right now. So what am I going to do? I need to undo what the 3 is right now. So what am I going to do? Come on, Kevin. Yes, I need to subtract 3 to make, which one are we making? Which one are we making? Big 0 or big 1? With adding and subtracting, are we making a big 0 or a big 1? A big 0, yes. Adding and subtracting is a big 0. Multiplying and dividing is the big 1. Because basically we're creating something on the left that doesn't matter. If I add 0, does it matter? No. If I multiply by 1, does it matter? No. These all should have periods at the end because they are sentences. Okay, last practice one. And then you guys are going to start your assignment in small groups. I'm going to have you in groups of 3 and 4, and you're going to work together to start your assignment. So your chapter 2 assignment 4. You get started on the homework in class today. What if I say 5x equals 30? Okay. To get rid of 5, I need to what? What's going on now? What would the opposite be? Because to make it turn into what we want, I need to divide, yes, by 5. Whatever's with the x is what we're dividing. To make, which one are we making? Which kind are we making? Big 0 or big 1? Big 1. Okay, so reminder, make big 0 for add and subtract. You make big 1 for multiply and divide. I'm going to use, I don't have it. Well, yeah, I could use this one and divide, because that's the divide symbol we're using anyway, right? All right. And the whole goal is to make the inverse, okay? The adding and subtracting, it's called an additive inverse because it turns it into 0, and adding 0 doesn't matter. The multiplying and dividing is called multiplicative. Lovely word, it's great. Multiplicative inverse, because we turn it into a 1, because multiplying by 1 doesn't matter. Okay. I now have remembered what the top says. An equation is a mathematical sentence with an equal sign. Okay, an equation is a mathematical sentence with an equal sign. So you know it's an equation because it has an equal in it. It's an expression, which is what we've been doing for the last several days and what you're tested on tomorrow, when it has no equal sign. Okay. Are there any questions? Okay, you are going to be broken into groups of 4. Let me see. There's going to be a couple groups of 3, I think. And you are going to work on your chapter 2 assignment 4. Okay. So do you see the chapter 2 assignment 4? Did it show up in the Google Classroom? Did it show up in the Google Classroom?